Well, here we have several questions to answer. The first one, it says find the zeros of f of x equals 1. F of x equals x minus 5 quantity squared minus 7. So to find the zeros of that, we'll just set f of x equal to 0 and solve. That is x minus 5 quantity squared minus 7 must equal 0. So isolating this squared quantity, adding 7 to both sides, we have x minus 5 quantity squared equals 7. So now we'll employ the square root property, and so we'll have x minus 5 equals plus or minus the square root of 7. Now to isolate x, we'll add 5 to both sides, and we get 5 plus or minus the square root of 7. And those are the zeros. The corresponding ordered pairs will be, 5 minus root 7, 0, and 5 plus root 7, 0. Done. Okay, for our second question, we have to graph, label the vertex and the intercepts of g of x equals x squared plus 6x plus 1. Well, to do that, let's find the y-intercepts. So we're going to evaluate g of 0, because the x-coordinate for any point on the y-axis is 0. And replacing x with 0, we get g of 0 equal to 1. Now we know the y-intercept. Now to find the x-intercepts, well, let's see. We know that g of x and the vertex, g of x equals x squared plus 6x plus 1, and we will complete the square. So I'm going to put parentheses around the x squared plus 6x, leave a space, put this 1 out here, and now I'm going to add 0 to this in a form that will lead to completing the square. So in order to complete this square, we need to, the third term has to be determined, and to do that we'll divide 6 by 2, the coefficient on x, and square it. And half of 6 is 3, square 3, get 9. But we can't just add 9 to this thing without violating that equal sign, so we'll add 0 in the form of 9 plus 9 minus 9. Now, the equal sign has not been violated. So, next step, we've got to get this negative 9 out of here. So, to do that, the coefficient on these parentheses is 1. You know, by the distributive property. To dispense with the parentheses, we just multiply each term by the coefficient on the parentheses. Well, in this case it's 1, so I can remove this negative 9 from the parentheses if I multiply it by 1. Well, 1 times negative 9 is negative 9, and it's outside the parentheses. And we still have this plus 1 here, don't we? So now that equals, hey, this is a perfect square. The square root of 9 is 3. Oh, boy. Whoa. The square root of 9 is 3, and that's quantity squared, and minus 9 plus 1 is minus 8. So now we know that the vertex, and by the way, this is g of x. Well, now we know the vertex is at what's the opposite of positive 3? Negative 3. And we still have this negative 8 here. And so there's the vertex. And we know that, we've been told that to find the vertex, you find whatever value of x will take this expression to 0. That's going to be the x-coordinate of the vertex. And then this constant here will be the y-coordinate of the vertex. So we have that. Now, let's find the x-intercept. So to do that, we're going to set g of x equal to 0. That is, we have x plus 3, quantity squared minus 8 equals 0. So x plus 3, quantity squared equals 8. Now we'll use the square root property. Now notice, I'm not going to take the square root of this. I'm going to say this. By the square root property, x plus 3 equals plus or minus the square root of 8. So x plus 3 equals plus or minus, and the square root of 8 is 2 root 2. So x equals, subtracting 3 from both sides, plus or minus 3 plus or minus 2 root 2. So the ordered pairs we're interested in are, the x-intercepts are, negative 3, negative 2 root 2, 0, and negative 3 plus 2 root 2, 0. So next step, we're going to graph. Now for the graph, we'll draw the axis. Let's see, x and y. And we know this, we have a vertex at negative 3, negative 8. So there's our vertex, and we'll label that negative 3, negative 8. We have a y-intercept at 0, 1. So 0, 1. And this parabola opens up because the coefficient on x is positive. There's our parabola. Now the x-intercepts are negative 3, negative 2 root 2, 0. And one more right there, and that's going to be negative 3 plus 2 root 2, 0. And let's see, we've graphed, we've labeled the vertex and the intercepts, we're done.